Intro to Pipeline Automation. Introduction. Today, automation is heavily ingrained in the software development lifecycle, SDLC, and DevOps processes. While this is incredibly good for production, allowing for faster development and deployment, it does, however, introduce new security risks. When these processes are manual, an attacker would have to compromise the credentials or workstation of the individual that performed the relevant process. However, with automation, an attacker can now go after the pipeline itself. DevOps pipelines explained. The diagram below shows what a typical pipeline can look like, as well as the software that could be used for this purpose. Let's see one by one in order. 1. Source code and version control. 2. Dependency management. 3. Automated testing. 4. Continuous integration and delivery. 5. Environment. Here we see the source code and version control. Let's take a look at source code and version control. This is the start of our pipeline. We need a location where we can store our code. Furthermore, we often want to keep several versions of our code since we are continuously making improvements and adding features. Source code storage. Source code storage refers to the practice of securely storing and managing software code in a centralized location. Developers use these repositories to collaborate, track changes, and maintain version history. We need to consider several things when deciding where to store our code. How can we perform access control for our source code? How can we make sure that changes made are tracked? Can we integrate our source code storage system with our development tools? Can we store and actively use multiple different versions of our source code? Should we host our source code internally, or can we use an external third party to host our code? The answers to these questions will help us choose the correct source code storage solution for our project. Version control. Version control, also known as source control or revision control, is the practice of tracking and managing changes made to software code and other files. We need version control for two main reasons. We are often integrating new features in our software. Modern development approaches, such as Agile, means we are constantly updating our code. To keep all of these updates in check, we need version control. An entire development team is working on the code, not just one developer. To ensure that we can integrate the changes from multiple developers, version control is required. Version control allows us to keep multiple versions of the code. This can be the specific version each developer is working on, but it can also be completely different versions of our application, including minor and major versions. Tools. The two most common source code storage and version control systems are Git and Subversion. Git is a distributed source control tool, meaning that each contributor will have their own copy of the source code. SVN is a centralized source control tool, meaning the control of the repo is managed centrally. GitHub is by far the largest provider of internet hosting for software development and version control using Git. You can create a GitHub account and use that to manage your source code repositories. However, you could also host your own Git server using software such as GitLab. For SVN, the two most popular tools are Tortoise SVN and Apache SVN. Security considerations. We want to make sure it is source code, not exposed. This is why authentication and access control for our source code is so important. We also want to make sure that changes and updates are adequately tracked, allowing us to always go back to a previous version if something happens. We also need to be careful about what we store as part of our source code. Source code cannot be fully secret since developers need access to it. As such, we should be careful not to confuse source code storage with secret management. We need to make sure not to store secrets, such as database connection strings and credentials, in our source code. Since we keep all versions of our source code, even if we remove the secrets in a newer version, they will still be exposed in the previous versions. Case study: Git never forgets. Version control can end badly for us if we make a mistake. This is a common problem when using version control tools such as Git. There is a saying, Git never forgets. Code is committed to a Git repo. When this happens, Git determines the changes made to the files and creates a new version based on these changes. Any user with access to the repo can look at historical commits and the changes that were made. What can often happen is a developer accidentally commits secrets such as credentials or database connection strings to a Git repo. Realizing their mistake, they delete the secrets and create another commit. However, the repo will now have both commits. If an attacker got access to the repo, they could use a tool such as GitLeaks, which would scan through the commits for sensitive information. Even if this information no longer exists in the current version, these tools can scan through all previous versions and uncover these secrets. To dependency management. Although we might think that we are writing a large amount of code when we develop, the truth is that it is only the tip of the iceberg. Unless you are coding in binary, chances are you are actually only writing a fraction of the actual code. This is because a lot of the code has already been written for us in the form of libraries and software development kits, SDKs. The management of these dependencies is a vital part of the pipeline. Difference between the external and internal dependencies. Tools. External dependencies are publicly available libraries and SDKs. These are hosted on external dependency managers such as PyPy for Python, NuGet for .NET, and Gems for Ruby libraries. Internal dependencies are libraries and SDKs that an organization develops and maintains internally. For example, an organization might develop an authentication library. This library could then be used for all applications developed by the organization. For these, we can use tools such as JFrog Artifacti or Azure Artifacts to manage these dependencies. See about the Metris and Demetris JFrog Artifacti. Pros. Supports 25+ package types, including Maven, NPM, NuGet, Python, Docker, and Hem. Available both for on-premise installations and as a SaaS solution. Fully hybrid with parity between versions. Cons. No major drawbacks reported by users. Azure Artifacts. Pros. Integrated with Azure DevOps services. Supports Maven, NPM, NuGet, and Python. Cons. Limited to the mentioned package types. Separate tool required for Docker and Hem. Security considerations. Some of the security considerations have been mentioned before. However, the primary security concern is that dependencies are code outside our control. Especially in modern times, where so many different dependencies are used, it is incredibly hard to track dependencies. If there are any vulnerabilities in these dependencies, it could lead to vulnerabilities in our application. Case study, Log4Shell. A zero-day vulnerability was discovered in Log4j dependency in 2021 called Log4Shell. Log4j is a Java-based logging utility. It is part of the Apache Logging Services, a project of the Apache Software Foundation. The vulnerability could allow an unauthenticated attacker to gain remote code execution on a system that makes use of the logger. The true issue? This small little dependency was used almost literally everywhere. Automated testing, continuous integration and delivery and environments. See in next video.